Hello, welcome to episode 3 of Making Terraria in Python. Today I'm going to be covering texture loading, so let's get into it. So texture loading is actually really simple, but I wanted to make sure that we have everything all down properly. So here we have our 3 entities that we created, and we want to replace one of their images with an actual proper image that we loaded in. So if you remember in the sprite.py, this entity class takes in an image and by default it is just a blank surface with a width of tile size and a height of tile size. We're going to be replacing this with an actual image that we load in. And you'll notice that at the top here I have this new folder called res, and this res folder has 2 things in it. It has a player and it has an atlas. And for now, let's look at the player. So the player is just an image that I ripped off of Google. This is temporary. We're going to be actually using our own sprites, but it's just a simple image of a Terraria player. So here we're going to be loading this inside of our scene.py. So I'm just going to take this middle entity here and then specify the image equal to pygame.image.load, and this parentheses, it takes in the file argument. So I'm going to do quotes, and it's a relative file path by default. So res/player.png, and then we want to do one more thing. We want to do .convert alpha, and we're doing this .convert alpha because we want to optimize the image for Pygame. If we don't convert it, then it's going to be a lot slower. And we did the alpha part at the end because this image has transparency. So we want to make sure this transparent is maintained whenever we load in the image. So now that we have done this, if we run it, you'll notice that our player is right here, but it is very large and it is all the way down there. And so there's a reason for this. One, the image is very large. Remember, our tile size is 64 pixels by 64 pixels, and this is something like 1100 by 1100. And then also there is a big gap at the top here. And remember that whenever we are using positions in Pygame, by default they are addressing the top left of the image. So it is loading in here and then drawing downwards. So let's go ahead and change this. Let's actually convert this image to the proper size. So for this, we're going to create a new variable, and this is going to be our player texture. And this is going to be equal to, and let's just cut and paste what we wrote earlier. So cut, paste, and let's actually scale this. So we're going to do player texture equals pygame.transform.scale. And this is going to take in the surface that we want to scale, so the player texture. And then it's going to take in the new size we want it to be, so tile size by tile size. And now instead of doing that image load right here, we're simply going to pass this player texture variable. So now if we go back to main and run it, you'll see that our image is properly scaled to the correct dimensions. Oh right, but you can see that there's a little bit of a problem here. While this is completely valid, the problem is that a game like Terraria has hundreds, if not thousands of images. So if we want to load them in like this, you can see how it can get pretty inefficient and pretty long. So I'm loading in maybe 20, 30 here, and you can see that it's a massive wall of text. And we don't really want to be repeating code like this for multiple reasons. One is just it's unnecessary, and 2, it is inefficient because we're loading everything in one at a time. And so this is where we get into things like the sprite atlas. And so we have this sprite atlas here, and if I zoom out, we have this block of images here, and you can see that I have 4 blocks here: the grass, dirt, top stone, and then regular stone. And these are 4 images on what's known as an atlas or a sprite sheet. And this is basically a sheet where you put a ton of different blocks all in one sheet. And there's a couple of reasons for this. One is it's more organized. You don't have to throw in all of these images into one folder, and it's a massive long list of images. It's instead just one image like this. And 2, it's faster. So whenever you're loading in 100 million blocks that are different types, you're not having to load in 100 million images. You just load it in on one sprite sheet. And so this is what we're going to be doing for all of our blocks. But you notice that our player is on its own image as well. And this is fine because we don't have to be ultra optimized. We don't have to put our player onto its own atlas and all that stuff too. We can temporarily at least have it on its own thing. We would just have to separate our images from the atlas images and the player images. And so now that we have a couple different concepts down, let's go ahead and create a new file. And this file is going to be our texture data. So texture data.py. And this texture data is going to contain 2 different dictionaries. One of the dictionaries is going to be for our atlas, and one of the dictionaries is going to be for our solo images, our images that are not on our atlas. So let's go ahead and create these. First, I'm going to import everything from globals. So from globals, import all. And then I'm going to create our atlas texture data. This is a dictionary, and then we're going to do our solo texture data. And our player is a solo one, so we're going to put it right here. And okay, let's go ahead and do this. So for this, we're going to create a key value pair because we're in a dictionary. And for the name, I'm going to do player static because this is just our static player image. And then we're going to do a nested dictionary for the value argument. This nested dictionary is going to have a lot of different arguments. So one of them, this one is going to be the type, and the type is going to be player for me. I'm actually going to lowercase it. I like to put everything in lowercase to not worry about capitalizing things. And then for the second key value pair, I'm going to do the file path. And this file path is going to be res/player.png. Then for the third argument, I'm going to do the size. And this is going to be a tuple with tile size by tile size. So now we have this image here and all of its data is properly organized into one spot. So we can go to our scene here and we can go to the imports and do from texture data, import solo texture data, and atlas texture data. And now let's create a new method for generating our textures. So we'll do def gen solo textures, send itself and pass it. And then we'll do def gen atlas textures, send itself and pass it. And now what we want to do is we'll generate our textures in this solo textures. So we'll create a new empty dictionary, called it textures. And then we want to loop through every texture inside of our solo texture data. So we'll do for, and then what we'll do is we'll do name data in solo texture data dot key or items. And this is looping through every single key value pair inside of our solo texture data. And then what we'll do is we'll do textures, and this will be, we need the name of this. And so for this, we're going to do the name equals, and then we're going to do a shorthand for this. So the pygame.image.load actually returns an image. So what we can do is we can take this and actually put it inside of this. And this is a valid creation of an image while you're automatically scaling it on the same line. So just a little shorthand for you. We don't have to do it like this, but it's a shorthand. So we'll do textures.name equals pygame.transform.scale, and this is going to take in the surface. So pygame.image.load, and then for this we want the data at the file path, and then we want to convert it alpha, and then for the size we will do the data at the size. And we're not touching the type ID here yet. I just thought that because we're going to be using it in the future, might as well put it in right now. So this is a valid loading of a texture. So now we just have to remember to actually return this dictionary at the end of our method here. So I'll do return textures. And I'm also going to explicitly say that this method returns a dictionary, just for my own sake. And now what we want to do is remove this player texture import and do self.solo textures equals self.gen solo textures. And then instead of passing in the player texture, we're going to do self.solo textures at, and then for the key, we're going to specify the name. And remember, the name of all the textures is the names in this solo texture data. So we want to load in this player static here. So we're going to put player static here, save it, go to main, run it, and you can see that while nothing changed, now we can load in a lot of images here. So while we only have one right now, you can see that this is a lot more efficient than what we did before, and it's a nicer way to organize things. Okay, now that we have done our solo texture data, let's go ahead and load in our atlas texture data. And this atlas texture data is not actually going to be loading in the image itself. We are going to simply do that the old-fashioned way inside of our scene.py. This is going to be specifying the data for our atlas textures. And so for this, we are going to do a similar format to this, but we just have to omit the file path. Let's just create some simple ones. So let's load in the grass one for now. So in the texture data, in the atlas texture, I'm going to do the name as grass. And then for the value, I'm going to do another nested dictionary. The type is equal to block. And then the size is equal to a tuple of tile size by tile size. And that's it for now. So now what we can do is go back to our scene, go back to the gen atlas texture, spell it correctly, and then do the same thing. So we'll create an empty dictionary called textures. We'll actually load in our atlas here. So what we're going to do is we're going to give it an atlas argument. So atlas, and then we're going to do atlas image equals pygame.transform.scale, pygame.image, image.load. In the parentheses, we'll do atlas here. I guess we won't do that. We'll do file path at file path dot convert alpha. The new size is going to be tile size multiplied by 16 and tile size multiplied by 16. And that is our atlas that we have loaded in. Now what we're going to do is we're going to simply loop over our atlas texture data and add every appropriate texture that we need taken from this atlas image. So what we're going to do is we're going to do for name data in atlas texture data dot items, and then what we'll do is we'll do textures at name equals, and here's where we're going to do another different Pygame method. So we're going to do Pygame dot surface with a capital S dot subsurface, and this takes in a surface as the first argument. So for this we're going to do our atlas image, and the second argument is a Pygame rect. And so this is going to have our X position, our Y position, our size, and our size. So we actually do need one more argument that I forgot. We need the position for our atlas texture data. So we're going to do comma, and then in the quotes we're going to do position, and then for the value we're going to do, for grass it's 0, 0 since it's in the top left. So now we can go back to our scene, and then in the rect we can do pygame.rect. This is going to take in the position and then the width and the height. And I don't remember if I can just send in 2 tuples for this. Let's see if we can. I think we can. Yeah, we can. Okay, so let's do data at, and then we'll do position, and then we'll do data at size. That should all work. And now all we have to do is remember to simply return the textures. Okay, so now let's do self.atlas textures equals self.gen atlas textures, and we want to send a file path, so res/atlas.png. and the reason I'm sending a file path is because we're going to have multiple texture atlases at some point. So now that we have this, we can replace one of our entities with the proper atlas image. So I'm going to do, for the first one, I guess, image equals, and this is going to take in self.atlas textures at grass. Save it, go to main, run it, and you can see that our first block is now a grass block. And so this is pretty cool because now we can load in multiple different ones. So let's go back here and let's make another one. Let's load in our stone block, which is 1 over. So all we're going to change is the position. So let's go ahead and do a comma. And then you can do Shift Alt down to duplicate your line of code to the bottom. And I'm just going to move it over by 1 and then change the name to stone. And now what we can do is we can just specify the third one to be image equals a self.atlas textures at stone. And we have an issue here. So let's see what that is. And the problem is that we are not multiplying it by the tile size. Okay, understandable. So what we can do is we can simply we could either multiply it here or we can multiply it there. And so I think instead of doing multiply by tile size for all of these, it's easier to go in here and multiply this position by our tile size. But the problem with that is that we're going to have to do this, where we do the first element multiplied by tile size, and then the data at position at 1, which is our Y, multiplied by tile size. A bit longer, but I think I might prefer that to doing multiplied by tile size for all of these all at, 1 by 1 like that. So there you go. Now if we run it, we have an error here. Oh yes, it doesn't take in that, it doesn't take in 2 values and then a tuple. So we're gonna have to do data at size at 0 and then data at size at 1. And then I'm gonna go ahead and press enter, put all these on their own little line here. Let's make it look a little nicer, please. Okay, now we have our stone block properly loaded in using this technique. And so as you can see, it's pretty good to use this method. So hopefully that wasn't too confusing and going all over the place. But yeah, I think organizing data, especially early on, can really help you with the scalability of your game, especially with a game as complex as Terraria. So that being said, thank you for watching. Have a good day. See ya.